Now we have seen how the IO is done. So if you see the way our devices are connected here, the units are connected like this. We have this ALU, addition and logical unit, and ALU is connected to accumulator. Accumulator is a resistor, and accumulator is connected to the bus, isn't it? And now there is an input resistor, and input resistor is connected to the accumulator, right? And ALU is also connected to the accumulator. And then there is data resistor, and data resistor is also connected to the ALU like this. It is also connected to the bus, and it can also take the input from the bus, right? And there is this output resistor, right? And output resistor is connected to ALU like this. So how is it connected to ALU? Is if you want to send anything onto the output resistor, you are supposed to send it to the ALU, and then ALU will send it to the accumulator. From accumulator through bus it has to come to output resistor. And then there is memory here. Memory is connected to the bus and like this, right? So now if you want to get an input from an input device, so this will be from the input device, this will be connected from the input device, right? So it is, let us say, IO interface, and IO interface will be connecting to the input device, and this one will be going to the IO interface again. So output interface and input interface. So what does it mean? Whenever the device want to send some data, it cannot directly send it to memory, right? So ultimately the destination for any input is generally the memory. So whenever you send anything, any data, it has to go into the memory and sit there, and later we are going to process it, right? And similarly, what is the destination of the output? Generally a printer or a screen, okay? So now if something has to come out from the memory, or if something has to go into the memory, if you look at it, always our ALU is involved, right? That is the way our computer is designed. So if you want to see this, if you are you understanding this? From input it has to go into the input register, and from input register it has to go into the ALU, and from ALU it has to go into the accumulator, and from accumulator into the bus, and then from here it has to go into the memory, right? And similarly, if you have to write something to the output, then from memory it has to come into the data register, isn't it? From here it will come on to the data register, and from data register it has to come on to the accumulator, and then from accumulator it has to go on to the bus, and from bus it has to get on to the output register. So anyway, if you are going to watch it, it is, I can simplify it like this. Our CPU is connected to the memory, and our IO devices are connected to the CPU, right? Which means if you have to send something onto the memory, you have to go through the CPU, and if you have to get something out, you have to go through the CPU, right? So why are we using this type of organization? Is because it is cheap and it is simple to build it. That is the reason. And now what are the disadvantages that we get out of it? There is only one way you can do the IO, that is through CPU. Now why is it a disadvantage? If you have to understand the disadvantage, you have to understand how the IO is being done by a program. I told you that in order to perform the IO here, we are going to write a program. So I have already shown you this in the previous video. We are going to have some skip if input flag is 1, and then branch unconditional, and then INP input. These three conditions, these three instructions we are going to have. Let us say this is at inst 200 and 201 and 202, right? And here it is going to be 200. Got it? So as long as data is not available, so how do you know that data is available? If the input flag is 1. So we are going to have a flag. As long as this flag is 0, we are not going to skip this instruction, which means as long as it is 0, we'll see this condition, we'll test it, we'll come to here, and again we go back, which means we keep on testing it, and whenever data is available, this one will be made 1 by the IO device. Then only we are going to read that particular data from the input register, right? And we have seen this in the previous video. Now what is the disadvantage of this one is, if you have to understand this, see this, it is IO program, let's say IO program, right? And the way that you are going to transfer the data using this IO program, that has got a name, it is called as programmed IO. Programmed IO, right? So the disadvantage is simple. Assume that in order to execute one instruction, the entire instruction cycle, instruction fetch and then instruction decode, execute, all this, everything put together, let us say is going to take 1 microsecond. Just an assumption. On average in our computer, assume that in order to execute one instruction, the time taken is 1 microsecond, right? 1 microsecond means 10 power minus 6 seconds, right? So for one instruction we are going to take this much time. Then in 1 second I could actually execute 10 power 6 instructions, which means 1 million instructions. That is also sometimes symbolically written as MIPS, million instructions per second, right? So that is the capability of our simple computer. It can execute 1 million instructions in 1 second, right? And now if you are struck with this IO program, let's see what happens. Now assume that the input is being provided by a typer through the keyboard, and the rate at which the input is being generated is, assume that 10 characters per second. Okay, so we are actually trying to transfer 10 characters in 1 second, right? Which means we actually need to execute only this particular instruction 10 times. See, every time you execute this instruction, 1 character will be moved in, right? But then in a time in which I could have read 10 power 6 instructions, I would have performed 10 power 6 instructions, which means this particular instruction could have been, we could have performed this particular instruction 1 million times, which means we have a capability to read the input at 1 million characters per second, isn't it? So try to understand this. Using this particular instruction, I could easily read 1 character from this input register into the ALU, right? Using this particular instruction, I could read 1 character, and now I have shown you that in 1 second I could perform 10 power 6 instructions. If every instruction is able to read 1 character, it means that in 1 second I have a capacity to read 1 million characters, but then input is being provided very slow. So input is only 10 characters per second. So in a time in which I could have executed 1 million instructions, or I could have read 1 million characters, I am just reading 10 characters because the IO devices are very slow. That is the case with most of the devices. So our CPU is extremely fast, it has the capacity to do the work very fast, but our devices are very slow. In such cases, writing this program is, of course, obviously a disadvantage. The reason is simple. Try to see this one. Now after we get every character, this particular flag is going to be set to 1. Now if 10 characters are being done in 1 second, then not to get 1 character we are going to have 0.1 second, right? Which is nothing but 10 power 5 microsecond, isn't it? 0.1 second is nothing but 10 power 5 microsecond, 10 power 5 into 10 power minus 6. So it means that we are actually getting the data at a very slow rate, right? but then we are checking these flags continuously. So what happens is, in order to execute one IO, in order to move one word from the input register into the ALU, I have to continuously be executing these three instructions, right? So if you see this, out of the total time, I'll be executing these two instructions over and again, and I'll be completely wasting the time. So this one is also called as continuously checking the flag. This one is also called as busy waiting. Busy waiting. So busy waiting is a term you might have already seen it in operating systems, right? Or if you can refer to that operating system syllabus, there I have explained it. So busy waiting is nothing but CPU is not doing any useful work. It is simply checking this flag, isn't it? So how many times will it check? It will keep on checking the flag until we are going to get a input in the input register. And how long is it going to take an input? 0.1 second. In 0.1 second, how many instructions would I could have executed? 10 power 5 instructions I would have executed, and now 10 power 5 instructions are executed, and all the instructions are these two, isn't it? Which means out of every 10 power 5 instructions, I am just transferring only one word. So these many instructions are getting wasted. Are you getting the picture? By using this method, in order to transfer just one word, I am executing 10 power 5 instructions, and these instructions are simply these two, right? So this instruction will be executed 10 power 5 by 2 times, and this instruction will be executed 10 power 2 times. Then only one input will be moved. So instead of wasting these many instructions, what is the better approach is, let the CPU execute the normal program, and whenever there is an input present in the input register, then let the input device interrupt the CPU. That is called as interrupt driven IO. So what is it? Now our CPU is not going to wait till the IO device is going to provide the input. CPU will be doing something else. Instead of busy waiting, CPU will be doing some useful work, and now whenever there is an input available in the register, it is the responsibility of the IO device to interrupt our CPU, saying that, see, a word is available, you please execute that input function. Then only our CPU is going to get the execute the input function. So that one is called as interrupt driven. So this one is called as programmed IO. Later again I will talk about this programmed IO. And now the next one is interrupt driven. Interrupt driven. So if you remember, in the last video while I was discussing about the IO, there were also interrupt instructions. There are two instructions at the end, ION and IO off, right? So these two instructions are used to modify a flag which is called as IEN, interrupt enable. So whenever this interrupt enable flag is 1, it means that the program which we are running can be interrupted, and if interrupted, that program will stop there, and we are supposed to go to the interrupt, process it, and again come back. In case if IEN equal to 0, it means that the program which we are running now should not be interrupted, and it has to be completed, then only interrupt will look at it. So why is it useful is, whenever you are running the program as a normal user, see, in our computer we are not going to have some specific, we are going to use the interrupt only for IO. In general, interrupt is going to be generated because of various conditions. So one condition may be the temperature sensor. So whenever the temperature in your CPU is very high, then that might lead to an interrupt, and that will be given the highest priority, right? And the other one is, there could be a timer for every program. For example, if you are implementing round robin, then no program is supposed to, let us say, execute more than 1 microsecond, right? Then you can have an interrupt for every 1 microsecond. Then the program which is being run will be interrupted, and the next program will be brought in and it will be run, right? There are various reasons we can use the interrupt for, but in our simple program and our simple computer, we are going to use the interrupt only for one reason, for IO, right? And now whenever an interrupt occurs, we as a user, normal user, if your normal user program is running in the user mode, it has to be interrupted. If the program that is running is in the super user mode, which means if you are executing some code which is related to operating system, then you are not supposed to be interrupted. So for that reason, we are going to have a flag called as IEN. So it is always preferred or preferable that you don't give this control to the user. If you give the control to the user, what he will do is he will say that my program should never be interrupted, which means he will just disable the interrupts by making it 0, and then he will not leave the CPU until he is done with this work. That is why in most of the computers, interrupt control will never be given to normal users. That will be given to the super user. Whenever you go to super user mode, then you have the control. Now what I mean to say here is, so whenever your program wants or allows an interrupt to occur while it is running, IEN should be 1. Whenever your program doesn't want to be interrupted when it is running, then this one will be 0. Got it? And assuming that we are giving the control to the user to set it, these two instructions will allow a user to set the IEN flag on or off. So if I have this, it means that interrupt is on, which means IEN is 1. If I use this, it means that interrupt is off, IEN is off. So whenever IEN is 1, it means that your program while executing should stop its execution and see or service the interrupt and again come back and execute. In case if IEN is 0, it means that your program, even if there is an interrupt, should not stop for checking the interrupt, it should continue with its execution. Got it? So now we shall see in detail how to implement interrupts in our small computer, but then I'm just restricting this discussion only to service the IO using the interrupt. Are you getting this? In general cases, in general computers, interrupt is used for a wide range of events for an exception, but then in our simple computer I'm just restricting interrupt to be used only for IO. We shall see that now. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.